Hey everyone, today we are going to be starting on our new chapter, chapter 3, in which we're going to be talking about averages. So when you think of average, you probably think of like mean, median, and mode, which is what we're going to talk about today. And also variation. So that will probably be a little bit more new stuff when we get into variation. Today we're going to take a look at mean, median, and mode in the first section. These are things that you probably learned starting back in middle school, and we're going to use today will be pretty basic, just a reintroduction of those. However, we'll see in the next lecture how we can take these a bit further and talk about things called like a trimmed mean or a weighted mean and go on from there. So let's go ahead and dive in. These mean, median, mode, these measures of average that we've learned before, in statistics, we're going to call those measures of central tendency. So when I say a measure of central tendency, what I'm talking about is a mean, median, or mode. Which means like sort of where does the data tend to go? In the center of the data, where is it? So that's what these three statistics do, is they try to measure the center of the data. The first one is probably the easiest one. That is the mode. If you remember from back in the day, the mode just refers to the data value that occurs most frequently. So whatever one you have the most of, that's your mode. Now it is possible that you could actually have no mode. So if every one occurs once, you would just say there's no mode. Or you could have more than one mode. Let's say you have 3 is the highest one, right? You have something that occurs 3 times, but 2 of the categories have it 3 times. So you could have multiple modes. The second one we'll talk about is called the median. Median, you can think of middle, actually, for the mode. Commonly we use for that, remember, is most often. For the median, the word you can think of is the middle, because that is the central or the middle value of an ordered distribution. So the key thing is often we're not given ordered data, we're just given some data. So the key thing is we have to order that first and then find the middle. And just kind of outline of the steps that you would use in order to do that. Again, we want to order the data from least to greatest. Then we want to find the position of the median value. It's not as easy as you might think. You don't just want to sort of like guess, oh, I think this is the middle. What you actually want to do to find the position of the median value, you're going to do what we'll say n plus 1 over 2. That n represents the number we have in our sample. So let's say we have 30 data values. We're going to do 30 plus 1 and then divide that by 2. Now you'll discover you don't always get a whole number. Let's say n is 30. Well, then we get 30 plus 1 over 2. So we get 31 over 2, which is 15.5. Well, we don't have a 15.5th data value, right? You could sort of think of them in a number line, right? We got, this is 4, 7, 8, blah, blah, all the way up. Then we got the 15th one that's here. Maybe this is 12. And then we got the 16th one. That's 13. And then we keep going on and on and on after that. So there's no 15.5th data value. So what we do in this case, this is the case when we have an even number. If n is even, then we average the two middle values. So if it's 15.5, then we want to consider the 15th and the 16th places. So we would average them. We would do 12 plus 13 divided by 2. So 25 over 2, which would be 12.5. You could also probably just figure that out, what's in the middle of 12 and 13, in this case, 12.5. So that's how we're going to do that. We are going to find the position of the median one. If it's an odd number to begin with, let's say n was 31, well, then it would be 31 plus 1 over 2, 32 over 2, which is 16. So you would just go to the 16th data value. You would start with the first one and count up to the 16, and the 16th one would be your median. All right. The last one is called the mean. The mean is what we typically think of when we think of the average. If someone tells you the average number of this, typically you just assume they're talking about the mean. And that's because it's the most commonly used method. It's also referred to as the arithmetic mean. Arithmetic comes from arithmetic, which back in the day, if you've ever heard the saying reading, writing, arithmetic was just sort of, they called math back in the day, addition, subtraction, all that stuff. All right. Now, finding the mean, you probably know how to do this from the past. We're going to sum up all of the data entries. So sum up all the numbers, and then you divide by the number of entries, the number of data values. So add them all up and then divide by how many there are. Now we are going to introduce some new symbols today. These we'll see more in future sections. But if you remember in chapter 1, we talked about how you could have a sample statistic. A statistic is actually some measure based on a sample of the whole population versus a parameter, and that corresponds to the whole population. So in a sample, we've just pulled out a sample of the population, and in the population parameter, we've actually surveyed or measured the entire population. So just some slight differences in variables. Don't need to be too concerned about it, but I'm going to go ahead and introduce these here. So for a sample statistic, the symbol that we're going to use is an x, lowercase x with a little line over top of it. And we pronounce this x bar. X bar. And the notation we use is x bar equals, and then we're going to use this. There's actually a Greek letter called sigma. We'll see this the more that we move on in the class. It means the sum of. So the sum of all x values divided by n. This is our formula. This means the same thing as what that says. It's just saying that the sample average equals the sum of all x values divided by the number in the sample. But this is just shorthand math using some Greek letters to show this same formula. So again, this little sigma thing here, that means the sum of. You might have seen this in another application as well. So the sum of all x values divided by the number in the sample. So that's what we do if we're talking about a sample of data. Now, if we're referring to a whole population, so let's say we wanted to find like the average age of all stat students. Well, if we just chose one class of stat students and calculate the average, that would be a sample. However, if we chose all stat students, if I put all 3 classes together and found the average age of all of the stat students in the school, that would be a population parameter. And so then we would actually use a different symbol. We're going to use this little U symbol with this little tail on it there. And this is actually pronounced mu. Mu is how I pronounce that. Again, we'll see that as we move on. And it's the same formula. I just say mu equals the sum of all x's divided by capital N, because capital N represents the number in the population as opposed to the number in the sample. So it's the same formula. We just switch out some letters. Don't worry too much about if you use the right letter at this point. Just note that these exist. And again, the x with a line over is called x bar. And the u with a little extra tail on it there is called mu. And I'll probably just use x bar in most situations. That's just used to refer to as the mean. Unless it explicitly says the population, you pretty much just use x bar. All right, so we're going to do 2 quick examples here. This data I got from the Licking County Health Department. Show you here. So this represents the confirmed number of COVID-19 cases the last 30 days. I think it was September 22nd through October 22nd. Yeah. So the last 30 days, the number of COVID cases in Licking County by zip code. So it's pretty interesting. There's definitely a wide range here. You can see there's a lot of zip codes that have zeros. Right here, here, here. A lot of them did have 0 cases in the last 30 days. But you also see that there is some that had a lot. So we got 107. This zip code is Newark. So that makes sense if we're talking about Licking County. Newark has the biggest population as well. You'll see here, the population 61,000. as opposed to one of the really low ones here. This one is 298 people. So I'm not sure what zip code that is. This one's got 81 in the whole zip code. So you can definitely see, well, there's a wide variety in here. I think this column over here, the rate per 100,000, is actually more informative because it tells you if one zip code, and in respect to the amount of people they have in the population, if they're having a lot of cases or not. Because you can see Newark has a lot of cases, but that's a decently high number, but it's actually lower than the zip code below it, which I believe this one is Heath, 43056. I think that's Heath. So although Heath has actually a lot fewer cases, 46, they also have a lot fewer number of people. And I could be wrong. That might not be Heath. I can't remember off the top of my head. I think it is. But you can see their rate per 100,000 is actually much higher. And then some of the other higher ones here, I think this one might be Pataskala, and then one of these was Reynoldsburg as well. So those are the higher population places. All right, so let's flip back to slide here. So I've got this chart here, and what we're going to do is we're going to use the data, which is active cases in this time frame. So that's going to be this column here. And so the first thing that you would want to do before you try to do any of these is to just write them all out in order. Just start with the lowest one. I would start with the lowest one. So start with 0, cross it off, go down, another 0, cross it off, another 0, cross it off. And it gets a little bit tedious to do this, but you do need to do that, get it all in order once you get to the bottom, and then start up the top again, go in order. So you do need to do that. Just in the interest of time, I went ahead and did that for this. So there's the data that's all ordered right there. And let's go ahead and do our 3 different measures of central tendency. So one would be the mode. Start with that one. So the one that occurs the most often, that's generally the easiest one to find. This one is pretty obvious. It is 0. So we need to figure out how many times 0 occurs. Just to double check. Like 1, 2, 3, 4, 5, 8, 9. It's like 11. 1's only at 2. So it's definitely 0. So our mode is 0. All right, the next one, let's go ahead and do the median. For the median, we need to actually figure out how many data values there are so we know which place to look at. We don't just want to guess which one's the middle. Another way you could do this is just sort of count, start in from both sides. You can, some people do this where you just eliminate 1, eliminate 1, eliminate 1, eliminate 1, and just sort of work your way in. That's sort of the less mathematical way to do it. If you had a huge amount of data, that could take a long time. The more, I guess you could say, mathematical way of doing it is determine how many data values you have. In this case, we actually have 24. So we use that little formula. 24, it's n plus 1 over 2. So 24 plus 1 over 2, which is 25 over 2. And that equals 12.5. So that's the place we want to look at. We want to look actually between the 12th and 13th place. So 1, 2, 3, 4, 5, 6, 7, 10, 11, 12. And then between the 12 and the 13th. So it's going to occur right in there. I'm just going to count the other way just to make sure. 1, 2, 3, 4, 5, 6, 10, 11, 12. All right. All right. So between the 12th and the 13th, it's going to be right here. So it's between 1 and 2. So you could probably guess what that's going to be. But if you wanted to actually write it out, it'd be 1 plus 2 over 2, 3 over 2, which is 1.5. So mode is 0, median is 1.5. And then lastly, we've got the mean, which if you want to, you can just write x bar. You just want to write that. So this is the average for the month, last 30 days from September 22nd to October 22nd. We're going to add them all up. Just type them all in your calculator. It's a good idea to always check this twice, but what you're going to be doing is 0 plus 0 plus 0. You don't have to write all this out, okay, if you don't do that. Type it all in your calculator all the way up to 107. So that means the sum of all x values, that was that sigma x, sum of all x values divided by how many there are. We said there was 24. And when I did this, I got 259 on top over 24. So 10.79 would be the mean. One thing to notice here is the mode, the median, and the mean are really different, right? You've got the mode is 0. The median 1.5, that's pretty close. The mean 10.79. Well, that's a lot bigger. So what you might want to think about is when you were to report the average of this data, which would be the best to use? And mean is actually a little bit deceiving in this one because most of the counties or most of the zip codes were under that 10 mark. If you look at all of these that were under 10, we only had 1, 2, 3, 4, 5 that were 10 or bigger. So mean actually can be a little bit deceiving in this case. So what you'll see is later in this section on the next video, we'll calculate something called a trimmed mean. And one thing you could do with a trimmed mean is, let's say we want to trim off 10%. So what we might do is might trim off this value because it's pretty big, and then we'd have to also trim one off the other side. So if we trimmed off those two values, that would significantly change the mean because we're taking this really big one, which we could refer to as an outlier because it's way higher than all of the other zip codes. The Newark zip code is a lot bigger because we got a lot more people. So maybe that one's an outlier. We don't want to consider it. So we could calculate what's called a trimmed mean, and that might give us a better indication of what this actually is. So keep that in mind for our next video. All right, and we're going to do one more problem here. This one, I took some polling averages since election is right around the corner. Might have already even happened by the time you watch this video, but at any rate, I took some polling averages from the website 538.com. And here's what I found here. They have all the polls listed, not all of them, but a lot of them from the whole month. You can see they took a bunch of different polls from all these different places. Siena, Trafalgar, YouGov, SurveyMonkey, ALG Research, all these different places. And I took all of those, the Trump and the Biden percentages, and then I averaged them together. And that's what we're going to do, average them together to figure out sort of what an average for Trump would be and what Biden would be for the state of Ohio. This site's interesting because they also give you how they would rate each poll too. They give each poll a grade. So the SurveyMonkey polls, they didn't grade very well. But they break down the methodology here for all these different polls, what's good or bad about them. So SurveyMonkey has an average error of, it looks like 7.1, and how often they were right in calling these. So some neat little insight you can get into those. We'll see how accurate these were. Pretty soon we'll get to determine how accurate all of these polls were in predicting the election. So that's always fun. All right, let's go ahead and take this data. Again, these are the poll results for Trump and Biden for all these different polls for the month of October. So what I want to do is figure out, well, on average, and this is a lot of times what these polling groups will do, is they'll take a bunch of different polls and they'll average them together to make their predictions. So I'm going to take all of these poll averages for the state of Ohio. So this would be actually a good exercise to do to make a prediction on who's going to win. We take all of the polling averages from the month of October. We're going to average them together and then see who comes out on top, Trump or Biden, and then you can make some sort of prediction about who's going to win, at least the state of Ohio. Nationally, it gets a little bit messy from there because, well, we have electoral college, and nationally the polls don't really actually matter that much. So we'll just hone in on Ohio. So I went ahead and ordered these for Trump and for Biden. So Trump there, I went ahead and just ordered all the results and do the same thing we just did. I want to find a mode, a median, and a mean. The mode for Trump looks like was There's actually two of them. So if we go through and look here, 47's got 4, 48 has 4, 49 has 3, 50 has 1, 2, 3, 4, 5 for 50, and 3, 4, 5 for 51 as well. So the mode is actually 2. It's 50 and 51. That's how you would write that. You don't take the average. You just say it's 50 and 51. The median, that's where we need to figure out how many values we had. And in this case, the n was 28. It's 28 poles. N equals 28. 28 poles. So we did 28 plus 1 over 2. It's 29 over 2. And that gives you 14.5. So that tells us we want to go to look between the 14th and the 15th data value. To go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 15. So it falls right in there. Now those are both 49. So if we're considering these, well, if you do 49 plus 49 divided by 2, well, you're going to end up with 49 again. So it is 49. Median is 49. For the mean, x bar, add them all up, divide by the number of data values. When you add all those up, you should get, I got 1362 divided by 28. And that gave me 48.64. So on average, Trump's getting 48.64% of the vote. And let's go ahead and switch to Biden. So I went ahead and ordered his as well. Get it to show up here. There we go. So there's his in order. The mode, first of all, on this one, it is 47. There's a lot of those. We got 1, 2, 3, 4, 5, 6, 7, 8, 9 47s. 3, 4, 5, 6, 7, 8, 48. So it is 47 because you got 9 of those. It's 9, which makes it 47. The median, since we have the same number of data values, same poll, it's going to be 28 plus 1 over 2 again, 14.5. 1, 2, 3, 4, 5, 6, 10, 11, 12, 13, 14. So we end up here, 47. Since we've got 47 on both of them again, it's actually just, 47. So median is 47, which actually happened to be the same as the mode. And then the mean, x bar, when you add all those up, we get 1307 divided by 28, which is 46.67. All right, so let's take a look at this data and see what it means. First of all, notice that there isn't a huge variation between these, especially Biden. It looks like he's pretty consistent there, close to 47, the mode 47, median 47, the mean pretty close to 47. So 47% is about where you would expect Biden to fall. For Trump, we've got 49, we've got 48.64 for the mean. The mode was a little bit higher. Probably is not as important in this one. The mean for Trump is about 2 points higher than Biden if we compare these two, right? The mean's about 2 points higher. However, you can't necessarily say conclusively that Trump's going to definitely win. The reason why is all of these polling, they always have some margin of error. And I want to just flip back here and show you real quick. Here's the simple average error for these polls. You can see some of them it's 5, some it's 7. So there's definitely a pretty wide margin of error on these. So a couple points either direction, let's say there were 5 points off, well, it could easily flip to Biden. So Trump being up by 2 doesn't really mean a lot. It does show you that based on the data, he is more likely to win, but there's simply no way to tell for sure who's going to win Ohio. So statistics are good, but they don't always tell the whole story, and you can't always make accurate predictions based on them. So reach out to me if you do have any questions about how to do these. Hopefully this is somewhat of a review, and good luck.